I've got my pen. Now, we were in the stomach. We passed through the pyloric sphincter, and we are now in the small intestine. And there are actually 3 parts to the small intestine, and so I feel like we should probably define those parts right away. So the first part of the small intestine that we enter is called the duodenum. Duodenum. The duodenum is pretty short. It's about 10 inches long. And it forms like kind of a C shape directly out of the stomach. The duodenum feeds directly into the next piece, which is called the jejunum. Jejunum. So check it out. Hey, look, they even labeled it here. Stomach enters into the duodenum. And then the duodenum, dude, they done forgot something. Really? That's just messed up because you forgot the jejunum. What do you think the next piece of small intestine is called? The ileum. I-L-E-U-M. Now, spelling and anatomy always counts. And ileum is a word that it is easy to forget that it is an E in the word ileum, especially since there actually is a bone in your pelvic girdle called the ileum, but it's spelled different. It's spelled with an I. So the ileum has an E because you eat food that goes through your ileum with an E. Piece of cake. The ileum is the longest. It's over 10 feet long. The jejunum, I think, was 7.5 feet long. Dude, the small intestine is huge. It's really long. And what's happening in here? There are 2 primary events that are taking place in this whole thing. Number 1, chemical digestion. And number 2, absorption. Chemical digestion. We're dumping in enzymes. Most of the enzymes are dumped in the duodenum. Enzymes and other juices enter here. And when we look at our accessory structures like the pancreas and the liver, check it out. You can even see it. We have ducts from the liver and the gallbladder and from the pancreas, and those ducts dump juice into the duodenum. And the juice that they're dumping is full of digestive enzymes that help you break down the food that's been mechanically churned in your stomach and chomped in your teeth. And now we need to break it down with chemicals so that it's really, really simple and small, so then you can actually absorb it into your bloodstream. And that's the small intestine, that's its job. Now, if the job is to chemically digest, then it makes sense that we're going to have a place where we can dump chemicals in, and that's in the duodenum. It also makes sense that we would have time to do that chemical digestion. And in order to have the time to carry out the chemical breakdown, the small intestine better be pretty long. Like your food better stay in the small intestine for a relatively long period of time. And it does because, dude, that thing, the length of the small intestine is huge. So it takes a long time to get through the whole thing, which gives you a lot of time to do the chemical digestion. If you are going to be an efficient absorber, then it makes sense that we would have as high a surface area in lining the lumen of our tube as possible. The more surface area you have, the more surface area you have to actually absorb the substances into your body. So there are several ways that the digestive system deals with this surface area issue. First of all, you have more surface area if you're long. So the length of the small intestine contributes to its ability to increase the surface area and be more effective at absorbing nutrients. The small intestine also has these structures called circular folds. And it's, you can't see them in this image right here. I'm wondering if I have any images where you can see it. But a circular fold, here's my tube. You got it? And a circular fold is just a place where the tube narrows, and then it gets bigger again. Okay, I have to draw you a picture because look at how a circular fold works. We'll make our digestive tube. Look at this. Here's my tube, and then it narrows down and then goes back to the original size. That's the circular fold. It's kind of a big, and gosh, this kind of makes it look like it has, you know, one finger that's coming out, but that is supposed to be one whole tube with these kind of constrictions around the whole tube. So if I went in and looked at it, I actually would see that, you know, this part of the tube would have to be this big, but this part of the tube, I could actually like fit a tiny little rubber band around it because it's actually narrower. But then you look at that and you're like, oh, dude, that's awesome because look, I now have an increased surface area, that as opposed to just that. Makes sense, right? Okay, so the circular folds are another way to increase the surface area. You also have structures all through the small intestine called villi, and this is really interesting too. So watch, in addition to your circular fold, which is the entire tube, narrowing, lining the tube itself all the way along, even in the narrow parts. Okay, so I'm going to take a cross section right here, and I'm going to draw you a picture of the tube from this aspect, from a cross section looking down it, and you actually have these structures called villi. Whoa, these are all villi. Do you even know what in the world I'm drawing? This is one villus. Here's another villus. Do you see that? These villi are finger-like projections extending into the lumen of the tube itself. So the tube narrows, but the tube is also filled with these finger-like projections that all they do is increase surface area. Now, there's one more thing that increases the surface area, and it's called microvilli. They are called microvilli. And I'm going to write it down here. Microvilli increase the surface area as well, but now I have to draw you a big picture. Look, I can even fit it on here. Are you ready? Now I'm just going to take a slice. I'm going to take one villus out of this picture, and this is what I'm going to do. Here's my single villus that's extending into the lumen of my tube. And we know that the villus is actually lined, what would you think, by what kind of tissue? Epithelial tissue, right? And we actually looked at this epithelial tissue. It's simple columnar epithelium. And so this whole thing is a villus. That whole finger is a villus. Are you ready to find out the amazing and fantastic microvilli? First of all, do you agree that this is one cell? A whole bunch of cells make up my villus. Guess what is on the luminal end of these cells? What? Little microvilli. So let me clarify this because this makes it look like they're not attached. I wonder if I can erase that. Oh, I love this program. Look at that. And every single one of them has it, except I just didn't take the time to draw every single one. But these guys, right, those are my microvilli. And this whole thing is a villus, or plural villi. We have a whole bunch of them. And they all line the lumen. What? So if you were going to do a compare and contrast, microvilli to villi, villi are made of multiple cells. They're an entire structure sticking into the lumen of a tube. Microvilli are similar little extensions, but they come off of a single epithelial cell. And we should be able to see those when we look in the microscope and do some digestive histology. Okay, we're going to talk about the accessory structures later on, so I feel good about this treatment of the small intestine. Let's look at the large intestine.